Centipede. Centipede.
Sup YouTube, Visual Gaming Network, and welcome to episode 32 of our Mario game in Java tutorial. Last episode we did part 1 of implementing Koopas into our game. This episode we'll be implementing part 2 of Koopas into our game. Now, before I get into this episode, you might be thinking, dude, it's been like 2 or 3 days since you were supposed to upload this. What's happened? Well, there's an annotation on your screen right now, or a link in the description, sending you to a video of me explaining why I am 2 or 3 days late of uploading the video. I pretty much had some pretty big problems that it took me a while to get around to fix. Right, so I'm sorry about this video being so late, and to make up for it, I'm actually going to release another tutorial, Mario tutorial, in the same week tomorrow. That's how sorry I am. And I even say that in the video I just told you guys to go to, so if you want to check that out, you can now. And also, I think people kind of forgot this, but as of me having 100 subscribers, which was about a month and a bit ago, you can actually suggest what topic you want me to cover in the next Mario tutorial. So to do that, just go into any one of my Mario programming tutorial series and just leave a comment of what topic you want me to cover in the next tutorial. I would read your comment, and yeah, I would cover it in the next topic. And people have actually suggested me topics before, and I've done them. That being the mini bosses and the launcher for our game. Now we're going to get into the tutorial. So we're going to have to create a few variables and other things at first. So first of all, we want to go into our states package, and we're going to create a new enum, and we're going to call it Koopa state, because our Koopa will go through states as it behaves. So there'll be 3 states in the Koopa state enum. First will be walking. The second will be, I think it's shell. And the third is spinning. Now we're going to go into our entity class in our entity package. And under our boss state, we're going to create a public Koopa state. And we're going to call it Koopa state. And yeah, we're putting it in here so we can use it in the Koopa class we created. So, by the way, if you don't remember, last episode we pretty much created a Koopa that pretty much behaves exactly like a Goomba, just without any collision detection. So, yeah. And as you can see, I've already made an integer called shell count that we'll be using in this episode. I don't know why I typed it there. Maybe I accidentally typed it there before the episode. But yeah, anyway, I'm just going to leave that there because we will be using it later in the episode. So, in our constructor, because we created our Koopa state in our entity class, which we're going to be using for our Koopa class, we're going to set Koopa state equal to Koopa state dot walking. Because when our Koopa spawns, or like when any Koopa in any Mario game spawns, it always starts off as walking, then it goes into its shell when we jump on it, then when we kick it, it spins. So now, we're going to go into our play class and pretty much program all the collision detection for it. And then we're going to actually make it behave and respond to that collision detection. So yeah, we're going to go into our entity for loop in our player class. And we're going to scroll down to else if e.getID is equal to id.coin. After that, we want to make another else if statement. And this time, we're going to be checking if our entity's ID is equal to id.Koopa. And if Koopa doesn't exist in your ID enum, just quickly create it now. So, anyway, in this if statement, we're going to have another 3 if statements. One, it will be checking if the Koopa state is walking. Another is checking if the Koopa state is in shell. And the third is if Koopa state is spinning. So we'll just do that now. If e.Koopa state is equal to Koopa state dot walking, and we'll just do that for the 2 other if statements I said we're going to be using in this episode. And last, else if e dot Koopa state is equal to Koopa state. Come on, I spell state wrong all the time. It's so annoying. State dot spinning. So we're gonna type the code in walking first. So in our walking if statement, we're gonna be checking if we are jumping onto the Koopa, so we know when to set its Koopa state equal to Koopa state dot shell. So to check that, we simply check if our get bounce bottom rectangle is intersecting our Koopa's get bounce top rectangle, and of course that's only possible when we're jumping on our Koopa. So we're going to type if get bounce bottom dot intersects, and in the brackets type e dot get bounce top, because we're referring to our entities or Koopa's get bounce top rectangle. And in that if statement, we're going to type e dot Koopa state is equal to Koopa state dot shell. So we just set our Koopa state equal to Koopa state dot shell whenever we jump on top of it. And you know when we were programming our mini tower bosses, that whenever we jump on it, we do a little bounce off it. We're also going to do that. So just scroll up a bit, and you should find these lines of code, and we want to copy that and paste it. And by the way, that's the code that makes our player actually bounce. So it should be in our e.getIDs equal to id.goomba or id.towerboss if statements. So yeah, anyway, I reckon that's pretty much our walking if statements done. Just one more thing. We're also going to be checking if any other part of our body is colliding with any other part of our Koopa. So we'll type else if gets bounds dot intersects e dot get bounds. So of course this will be called when we collide with our Koopa, but we're not actually jumping on it. And of course, when this is true, we're going to make our player die. So now we're going to go to the shell if statements. So in here, we're pretty much going to be checking if we're jumping on our Koopa or kicking or colliding with the left or right of our Goomba when it's in its shell, or its Koopa states, wow, is equal to Koopa state dot shell. Because when we're colliding with it, with our Koopa and it's in its shell, we always kick it. So yeah, so in this statement, we're pretty much going to make the player kick our Koopa when necessary. So first, of course, we're going to be checking if we're actually jumping on our Koopa. But to do that, I'm just going to quickly copy this get bounce bottom if statement in our walking if statement. Not the else if, just the first if statement. We're going to copy it, and we're going to paste it. But the thing is, we actually need to set the Koopa state equal to Koopa state dot spinning, because we just kicked the shell, and we want to set our Koopa equal to Koopa state dot spinning once we've kicked it, because you know when we kick it, our Koopa starts spinning on its shell. But we don't actually make it move left or right when we kick it, and that's what we're going to do now. We're going to go into our Koopa class, and in our constructor, you'll see that there's a switch dir and an int dir sort of lines of code that are called when we create our Koopa, so it'll make our Koopa start walking in a random direction. So we'll copy that, go into our player class, and paste it into our get bounce bottom if statement in our shell if statement. And as you can see, we get an error because we're trying to use a variable called random in our player class that doesn't exist. So yeah, we haven't created a random object, so we're just going to quickly do that now. Scroll to the top of your player class and create a private random object, call it random, and set random equal to a new random. Oh, I put the semicolon in the wrong place. Anyway, we're going to scroll back down. And in our switch, we just want to change 2 to 10 because if we keep vel x at 2, that will mean whenever we kick our Koopa, it will start like only moving from left to right at a vel x of 2, and that's pretty slow. That's pretty much our Koopa's walking speed, and we don't want that. We want it to go a lot faster. Usually in Mario games, when we kick our shell, it starts moving faster than the player. So we're going to actually set our vel x equal to 10, which is actually twice as fast as our player, and our player's vel x is 5. So yeah, we haven't quite finished with our shell if statement yet. We also need to check if the left or right of our player is colliding with our Koopa, and not just checking if we're jumping on it, because we can kick our shell by hitting it on the left or right as well. So of course we need to check if our get bounds left if statement is intersecting our Koopa's get bounds right if statement. And if that's true, we want to set e.vel x equal to -10, and that will make our Koopa move left. And of course, we have to set e.KoopaState equal to KoopaState dot spinning. There we go. And also, we're going to do the same for a get bounds right if statement. So this time we're checking if our player's get bounds right rectangle is intersecting our entity's get bounds left rectangle. And if that's true, we're going to set vel x equal to just +10 this time. And of course, still set our entity's Koopa state equal to KoopaState dot spinning. And by the way, I just realized in our direction switch, or whatever you want to call it, in the switch we actually set our player's vel x equal to -10 and not our entity's vel x. And that's a bad thing, because that will pretty much make our player move, because if we don't change it, our player would move it at a vel x of 10 and not our Koopa, and we'll be thinking, what the hell? And yeah, we don't want that. So to fix that, we want to set our entity's vel x equal to -10 instead of our players. So to fix that, we just simply put e dot at the start, and that'll tell Java that we in fact want to set our entity's vel x equal to -10 and not our player's vel x. So now that's our shell if statement done. Now we're going to move on to the last if statement, the spinning if statement. As you might have seen in Mario games, whenever we jump on top of a shell that's being kicked and it's spinning, it actually stops the shell from spinning. So we're going to do that now. Scroll back to our walking if statement. We're going to copy all the code in that if statement, paste it into our spinning if statement, and we're actually going to change nothing. It's the exact same code, because whenever we jump on top of a spinning shell, it goes back to a normal shell, so we don't have to change any code. So yeah, that's pretty much our collision detection done. We might come back here if I discover a few bugs, but other than that, we should be fine for our player class. So now we're going to go back into our Koopa class. Now actually, we'll run our game and see how everything's going. Of course, everything won't be perfect. There'll still be things we need to do. Oh, one thing I forgot to do is that I'm lazy as usual, and I don't make any sprites for our Koopa. So I'm going to color code our Koopa. In our render if statement, I actually just set the color equal to color.green, then filled a rectangle. And color.green gives you a nice light green color. And we want that green color to show when our Koopa is walking. So to do that, we put an if statement at the start of the line of code, and we'll check if Koopa state is equal to KoopaState.walking. Then under that, we're going to make an else statement, and this will be called whenever our Koopa state is equal to KoopaState.shell or spinning. And we're going to type else g.setColor. We're going to set the color equal to a new color, and the RGB value, or red, green, blue value, would be 0, 128, 0, and this gives us a nice dark green colour. So now let's run our game. Of course, as I said before, everything won't be perfect. There'll be lots of things that need to be polished. But anyway, we're going to jump on top of our Koopa. As you can see, that it becomes the darker green colour, which means it in fact is a shell, but it's just still moving, which is something we have to fix. And if we actually collide with our Koopa, as you can see that we kick it and it starts moving. But yeah, as you saw, it still kicked and moved at the speed or rate that it should be moving at. But as you can see, when it hit the wall, it actually went back to its walking speed. And the reason why is because if you have a look in our Koopa class's tick if statement, look in the tile for loop. As you can see, whenever we collide with a tile, then it actually sets our velx to 2, which is our walking speed. So to fix that, we just change 2 equal to 10 and -2 equal to -10. But the problem with this is, when our Koopa is walking and actually collides with the tile, it'll start moving at its spinning speed. So now to fix that, on the start of the line of code, we're going to make an if statement. We're just going to be checking if Koopa state is equal to Koopa state dot spinning. And if that's true, then we set velx equal to 10. And we'll do the same for the other line of code in our get bounds right if statements, but we'll just set velx equal to -10. And under that, we're going to make an else statement, and we're going to type else set velx equal to -2. And of course, this line of code will get called when our Koopa is actually walking and not spinning. And one more thing we have to clear up. You probably saw when we actually jumped on top of our Koopa and it turned into a shell that actually kept moving, and we don't want that. So to fix that, we're going to make another if statement in our tick method. We're going to be checking if Koopa state is equal to Koopa state dot shell, and if that's true, we're going to set our Koopa's velx equal to 0, and now we'll of course make it freeze. So now let's run our game, try everything out. Oh, and I forgot to show that our Koopa actually goes back into its shell when we kick it while it's spinning. What the hell? Did you see that? I do not know what happened. What? What is going on? Wow, I'm gonna take a quick look at the code and I'll be back. It didn't take me too long to figure out. What I did wrong is that in our get bounds left if statement, in our else statement, I actually set velx equal to -2, which makes our Koopa keep on going left. I meant to take away the negative and make velx a +2. So we'll run that. Nothing with collision detection should go wrong again. That was kind of funny. So anyway, let's jump on top of our Koopa. As you can see, that our Koopa has turned into a shell and it's just staying there. And if you didn't realize, we actually did a little bounce off of our Koopa when we jumped on it, like we do a little bounce off our tower boss when we jump on it. So anyway, let's kick our Koopa. Alright, as you can see, we kick it, and when it hits a wall, it keeps going at its spinning speed. So yeah, that's that out of the way, and of course we can still collide to the left of right of our Koopa, and we'll still die like we should. So anyway, one more thing we have to fix. I'm just going to show you this. In actual Mario games, you might not have realized this if you're like trying to like speed run or didn't bother to watch a Koopa for a certain amount of time in a Mario game, or at least the 2D Mario games. But anyway, after about 5 seconds or so, what am I trying to say? When the Koopa is in its shell, after about 5 seconds or so, it actually pops back out of its shell and it goes back into its walking state again. And if we jump on top of our Koopa, we actually haven't programmed our game to make our Koopa go back into its walking state after about 5 seconds, and it just stays in its shell forever until we actually do something to it. So, whoa, I just realised if we try to jump, and my bad. Yeah, I just realised that I jumped on top of the Koopa, it didn't go back into a shell, and I was wondering, oh, that's a bug we have to fix. But I jumped on top of it again, and it just went back to its normal shell, and yeah, I just realised everything was right. So yeah, anyway, we're going to actually make our Koopa pop back up after 5 seconds. So, and this is what our shell count is for. Like the integer that wasn't really supposed to be there at the start of the episode, but it was. That's pretty much what it's for. So yeah, anyway, we're going to go into our tick method. And you see our if statement where we're checking if our Koopa state is a shell. We're going to give that if statement a body, so just some curly brackets and press enter. And under set val x equal to 0, we want to type shell counts ++. So under that, we're going to be checking if shell count is greater than or equal to 300. And the reason why I say 300 is because if I scroll through the console, you can see most of the time our game actually runs at 60 ticks per second. And because we want our Koopa to stay in the shell for 5 seconds, 60 times 5 is 300. So approximately 300 ticks for our Koopa for 5 seconds to pass in real time. So yeah, that's why we're checking if shell count is equal to 300, because we want our Koopa to stay in the shell for 5 seconds. Anyway, back to the code. We'll just give the if statement a body, and if that's true, we're going to set shell count equal to 0, Koopa state equal to Koopa state dot walking, and everything should work. Let's run our game. Alright, we'll start our game. Alright, we'll go to our Koopa. We'll jump on. Fail. Okay, let's try that again. Alright, as you can see, our Koopa is in its shell, and after 5 seconds, it should go back to its walking state, but as you can see, our Koopa is not actually moving because we haven't told our program to make our Koopa walk again whenever it goes from its shell to walking state. So we're going to do that right now. Under our if statement where we're checking if our Koopa state is shell, we're going to make another if statement. If Koopa state is equal to Koopa state dot walking, or Koopa state is equal to Koopa state dot spinning. So of course this if statement will get called when our Koopa is not in its shell, and if that's true, we want to set our shell count equal to 0. And why we do that is because, let's say our Koopa is in its shell and we kick our shell, but what happened is that when we kick our shell count is never set to 0. So let's say when we kick our shell count is equal to 270. When it goes back into its shell, it'll only take 30 more ticks to go back to its walking state instead of 300 ticks, because our game is picking up from where shell count left off. So yeah, just for safety reasons, whenever our Koopa isn't in its shell. So yeah, after that, we're going to check if val x equals 0, and of course this will occur when our Koopa pops up from its shell, goes in to its walking state again. And if that's true, we're just going to copy this dir switch thing again and just paste it into here. So anyway, let's run our game. Alright, we'll start our game. jump on top of it. Alright, as you can see, it's in its shell. And after 5 seconds, it pops back up and starts walking again. So yeah, that's pretty much our Koopas done. Anyway, I'm going to wrap up this episode here. If you enjoyed, feel free to leave a like, a comment and subscribe. If someone you know is interested in learning how to program a game in Java, please let them know about this channel. Remember to suggest what topic you want me to cover in the next tutorial. And if you have a Twitter account, please feel free to follow me on Twitter. So see you guys soon. Bye.